I've started more than one video like this. There's Caboose holding the fort down again. That's right. Can't stand me being on the other side of the door. Love you too, buddy. I've got a 6-bolt and a 7-bolt short block that I get to showcase. Guess what? I was gonna break this up into multiple videos, one for each, but the more I looked at it in the edits, the more I realized it just didn't make sense. So, you guys asked me for longer videos, and it's payback time. This one's a doozy. I'm going to go through both the 7-bolt front case that came out of my GSX and put together a 6-bolt oil pump for the engine it will be receiving. My new 6-bolt will not have balance shafts. I've laid out most of the stuff I know I'm going to use, but I may take a few toolbox trips depending on what else I decide to take apart. I need a straight edge and feeler gauges to inspect the oil pump gears, my one and only snap-on tool in my toolbox, an extruded aluminum scraper that I'm extremely proud of. I mean, damn, that's one nice scraper. Red thread locker, a long shank flathead screwdriver, Allen wrenches in case you take your 7-bolt front case plug out. They're both the same, and I only need one of these, but I grabbed both just in case. A bunch of sockets for bolts and pressing in seals, my new 18-volt cordless half-inch impact that my mom bought me for Christmas, which was greatly appreciated and I love it. Thanks, love you, Mom. My crappy Harbor Freight micrometers, the seals and gaskets I blabbered about in another video. Impact drivers are necessary if you're working on a 7-bolt front case. It keeps you from stripping the tapered head machine screw on the oil pump housing. One whack does it. Just make sure you brace it with a block of wood underneath. You see the rubber seal where the balance shaft gear used to be. The block it came off of already had a balance shaft delete performed back in 2004. Almost a decade and 48,000 miles later, wouldn't you know it, I'm installing a 6-bolt. This front case has 150,000 miles on it. It's the one that came from the block that was full of broken glass and BBs. I gave it away and the person I gave it to gave it back to me, so I guess this was meant to be. I've got the oil pump housing, I've got all the gears, got the bolts, and you can tell where these go on the front case based on their grades. This one was once a physics scholar. No, really, the grade 10 hardened bolts go on the shafts, and the grade 4s go on the pump. The aluminum pump housing doesn't see anywhere near the torque loads that the gears require and use softer bolts. If you use lesser grade bolts on a balance shaft, they'll break off while you're torquing it. Don't do that. There's nothing special about the balance shaft gear. It rides on an oil journal that's sandwiched between the gear and the shaft. If you're reusing this with balance shafts, make that oil journal part of your visual and thumbnail inspections. It's what the seal rides against to prevent oil leaks. There's the oil pump gear. Unlike the balance shaft gear, the oil journal is built into the gear. If you question it or previously had an oil leak here, replace it. There's a pair of good 6-bolt turbo balance shafts. You never know, they may come in useful someday. This is something like what you'd see after separating the front case from the block. It's dirty, gasket stuck to it, a little bit of funk from the crankcase, but it's mostly clean thanks to running only synthetic oil. Cleanup is pretty easy. You scrape the parts of the gasket off with a razor blade that don't just break off on their own, and take care not to scratch or gouge the gasket surface. It needs to be clean and flat. You don't want any of the remnants of the old gasket on the raised gasket surfaces hanging around if you're going to reuse this part. It's much easier to scrape it without damaging it if it's still oily, so save all the solvents for last. Some people soak them in gasoline or kerosene, and that works great to break up caked on grit and grime, but if it doesn't leak and just has belt dust on it, carb cleaner and a razor blade works fine. Removing the seals with the case on the workbench is a piece of cake. Just be aware that there's an inner lip behind the seal that you could easily break off if you pry against the wrong spot. You want to be careful not to gouge the outer ring of the seal surface, but it's okay if you scratch that inner lip below it because nothing touches it. I just twist the screwdriver without inserting it all the way into the seal boss to pop one edge and then pick it out. Someone asked me in a recent video about the groove that the seal cut into my crankshaft. They wanted to know if there was a method to repair the groove. Yes, but don't mess with trying to repair the groove on the crankshaft. If you put a new seal on the engine and it's still leaking, you can actually fix it. Of course, you should use the same kind of seal and a new one to replace it, but it can be modified. The seal has a spring behind the rubber grooved lip that keeps it pressed against the oil seal journal. It's a specific length for the diameter of whatever part that fits through the seal. You can remove it, twist the seam on it, and unscrew and separate it. Then use some extremely sharp precision dikes to nip a couple of coils on it. No more than 2, and put it back together. Be careful not to bend and distort the coiled end. You should twist it 2 revolutions the opposite way before screwing it together again. The tension from twisting it should hold it together, and the result is a slightly tighter seal.
Unless that groove is deep and leaks with a brand new seal, don't bother with it because it'll just wear the seal and the part faster. While you're taking the front case apart, inspect the seal surfaces as you remove them. If you break stuff or if it's already broke, the point at which you discover these problems determines how useful this part is to you and how long to spend on cleaning it up. If you discover cracks, deep gouges on sealing surfaces, or anything that doesn't look perfect on the oil pump, replace it. So with that said, here's the balance shaft plug. This is the oil seal for a 1.6 liter Mirage. They don't leak like those stupid metal freeze plugs that are never perfectly round. You can crack or distort the front case pressing the freeze plugs in. Add crankcase pressure and they always leak. JB Weld is messy. Stop it. Use the rubber plug instead of the freeze plug that comes in most balance shaft removal kits. This is where the dry shaft goes, and we'll talk about why I call it that later. It doesn't touch anything in the front case except for the oil seal. Don't lose track of the cylindrical seal journal that bolts between the gear and the shaft. If you're reusing the balance shafts and the oil seal groove is too deep, you can just flip it over and use the other side where there's no groove as long as it's not pitted or rusty. But I don't need any of this stuff. I'm just playing around here. Let's see what this oil pump looks like. I've already removed the tapered screw, but there's no gasket between the gear housing. Nothing. You don't want it there, and I'll explain this during assembly. You shouldn't need anything to pry it loose, but if you do, go for the edges that don't have milled surfaces. It's just 2 dowel pins aligning it to the front case and it should come apart easily. Both gears need to come out for a full inspection. To take the drive gear out, one 14mm nut holds it on. If you were smart, you broke this nut loose prior to removing the timing belt. Check the oiled bearing surfaces thoroughly and look for damaged gears or scoring on the oil pump housing. The oil pump drive gear has a pair of oil holes inside an oil groove that receive their oil supply from the rear oil pump housing through the fat end of the shaft. Obviously it doesn't go all the way through, but it's hollow in the center. If it were good enough to reuse, you'd want to clean that out before assembly. Even though the oil pump seems to turn freely, this one's foobarred. Let me show you why. The oil pump housing is deeply scored from the chunks my rod bearings dropped in the oil supply, and this has rendered the housing useless to me because you can't fix this. Deep grooves like this will reduce the oil volume the pump is capable of moving, but there are also grooves on both sides of the oil pump driven gear shaft and inside the housing's bearing surfaces. I don't feel any lateral play in the pump gears, but these should be smooth. This is what happens from oil starvation, not from digesting chunks. Something else is wrong here, so I'm digging deeper. The process for removing the oil pump seal is the same. Be careful of the seal boss and just pry against the outer lip. Check the drive gear's oil journal for grooves and inspect the seal bosses. Finding any chunks behind the oil seal is a very bad sign here because this is the oil's last stop before it reaches the pan. The oil had a long way to travel to get here, and since I found a chunk, this engine's just turned into a marvelous learning opportunity. However, things are looking good if you don't find anything wrong with your front case up to this point. Clean it out with carb cleaner, give it another dry inspection, use your fingernail, and if you can't feel the grooves, it might be okay. I'll show you a more precise method to check it with in a minute. Some wear is normal on an oil pump, but if you didn't suffer an oil-related engine failure, more than likely the pump is good. A properly serviced engine only fed clean oil should not show any of the signs you've seen here on this front case. I'm only cleaning this for demonstration purposes and because I don't want to get my tools dirty. I'm already convinced this thing's junk. Man, this thing feels terrible. I have to remove this weird Allen screw to get a better look, and I've already stripped the shit out of it. That'll be fun. Be aware of the oil pump gears having alignment dimples punched into their butts, but you really only need to do this if you're maintaining the balance shafts in your build. They're butts instead of faces because they both go against the rear housing. They don't face the front. If you're not running balance shafts in your build, you don't need to align the dimples of the oil pump gears. Their purpose is to help line up the balance shafts inside the engine when you set the exterior markings of the timing components on the cams, oil pump, and crankshaft to top dead center. The timing gear is keyed so you can't install it out of phase. Setting the balance shaft position is the thing you read about in the service manual, removing some plug and sticking a screwdriver through the block for the front shaft. I will never cover that in a video because I insist everyone uses a service manual for instruction over my videos. However, I always line up every last mark solely out of my own insane superstition. I don't ever want to hear anyone saying, "Jafro, if you had only lined up the oil pump dimples, this never would have happened." Moving on. If you have a 7-bolt front case, there's an 8mm plug on one end, and there's nothing really special about it. It just gives you access to the high pressure side of the main oil pump gallery. Perhaps there's a tool that lets you check oil pressure here, or perhaps it's just for cleaning. I don't know. Seems like anything you attach here would interfere with timing components, but let's pull the plug and see what's inside. Air. Just a bunch of air in here. Oh, and look, there's some metal shavings. If you wanted to, you could use a bottle brush in here and scrub it out with carb cleaner, but I already know it's not worth ruining a bottle brush. You guys can figure that stuff out for yourselves. The 1G front case doesn't even have this, so unless your oil pump ate chunks, you should just leave it alone. Just soak it and wash it out. Another thing to leave alone is the castle plug that's partially obscured by the oil pump timing gear. They don't leak until you mess with them, so don't mess with them. The purpose of this plug is to give you access to torque the grade 10 bolt that holds the balance shaft to the driven gear. Hey, I got a great idea. Just do that in a vise with some soft jaws, mark it on the opposite side of the gear where the dimples are with a Sharpie, and assemble the front case on your workbench. Problem solved. You can insert the front case into the block with the balance shafts installed and bolted through it, so why put yourself through the annoyance of messing with the castle plug? How does this part ever wear out? You'll typically destroy this plug and scratch up the case while attempting to remove it on the workbench. The only real benefit it offers is unbolting the shafts from the gears through the front case so you can remove the oil pump without pulling the whole engine. Tell me why you'd ever need to do that. Can anyone? I can't figure it out. If your oil pump failed, the front case is the least of your problems. It's less time and mess to just pull it with the balance shafts attached and do this on the stand so you can inspect all the other stuff that was destroyed in the process of trying to get your attention. Save your back all the grief from doing this with the motor in the car. Let's look at some of the other differences between the 6-bolt and the 7-bolt front cases. The 6-bolt front case is flat at the bottom, and so is the oil pan. The 7-bolt has a lump on the bottom. The oil filter housing holes and location aren't the same. The oil return from the oil pump drive gear is drilled into a different return location on the back of the front case, but not off by much. The 7-bolt has 2 bolt holes for the crank angle sensor. The 6-bolt engines don't have a crank angle sensor at all. There's also 2 oil pan holes on the bottom of the front case for the 6-bolt motor that require shorter bolts. If you don't install the shorter oil pan bolts here, it'll cut a groove into your timing belt. The 7-bolts don't really have this problem, but if you try to use a long bolt in the rear edge of the block, you'll find that the bolt bottoms out before it makes it all the way into the bore. Some of the bolts that hold the front case to the front of the block are different lengths. Some of their locations are even different. The 1G and 2G timing belt tensioners are different, and the mounting holes for them on the front case also reflect this. The oil filter housings line up differently on 6-bolt and 7-bolt engines. Barring these differences in size and shape, the bore locations for the balance shafts and oil pump gears are the same, no matter 6-bolt or 7-bolt. The flow characteristics of where the oil goes and what parts receive lubrication and when are the same. The drive and return gear gap specifications are the same, and so are their sizes and lengths. The 6-bolt uses straight cut oil pump gears and the 7-bolt gears are helical cut gears. Everything I've covered in this video so far applies to either generation of parts. So let's inspect the oil pump gear clearances on this beast. This is the only inspection requiring measurement that's listed anywhere in the service manual. The drive gear spec is between 31 and 55 10,000ths of an inch. 3 thousandths on mine is like throwing a sausage down a hallway, but it's supposed to be like that. Let's try the 6, a half thousandth over spec. The 6 thousandths drags and disturbs the straight edge a bit here. It almost fits, but you really don't want it to. This would fit if I forced it, but 6 would be well past its end of life spec of a 5.5 thousandths. It's disturbing that it nearly fits under the driven gear. The driven gear spec is 24 to 47 10,000ths of an inch. The 6 thousandths doesn't fit, but let's try the 5. The 5 fits easily, so we're between 5 and 6 thousandths of an inch here, probably closer to 6. You really don't want this one to fit on the driven gear because the loose spec is 4.7 thousandths and 5 is, whoa, well, this is more like a basketball down a storm drain, but it's every bit as disappointing. I want to check the drive gear's shaft oil clearance just for giggles. I've showed you guys how to use these before. After I lock it with a good measurement, I check the whole bore to see if the resistance changes anywhere. You know what it means if it feels tighter or looser in any spot. This one's really consistent. Now you just measure the telescoping gauge and get the bore diameter. We've got 786.5 thousandths of an inch. We just need to subtract the diameter of the oil pump's gear shaft from the bore diameter. So we measure the gear and we get 785.25 thousandths. 786.5 minus 785.25 is 1.25 thousandths of an inch. That's extremely tight for an oil clearance. I was just curious to see what this measured. I had to drill my 7-bolt stub shaft in order to set it free from the gear because it was so badly seized. I missed the video taking the camera rolling for granted, and it wasn't rolling. Nope, sorry, missed the video. But what I found when I removed the stub shaft shocked me. There's no oil groove for the driven gear. None. I don't need oil holes to deliver oil to a balance shaft, but the groove serves as a gallery to supply the oil pump drive gear. Both parts on my oil pump were destroyed by this. Circulating unfiltered metal shavings as my rod bearings went certainly didn't help anything, but this is supposed to receive filtered oil. It shouldn't have seen any chunks of any kind on the shaft bearing surfaces. Yet both the housing and the shaft are deeply grooved. It's because the lack of oil groove in the stub shaft deprived not only the drive gear's shaft, but the bearing surfaces of the stub shaft as well. It went from a 360-degree oil supply to a 6-degree oil supply by having a flat journal. I didn't know this about the oil system when I bought and installed this part. I bought it from a reputable shop. I saw it discussed years later in a forum, and now I'm finding it in my fragged short block. If you supplied the wrong part to your machinist, engine builder, or failed to catch this problem on your own, you only have yourself to blame. You can't expect anyone else to know how your oil system works if they don't specialize in serving that kind of equipment. Apparently, you can't expect aftermarket parts manufacturers to understand how your oil system works either. That's the bottom line. You're the last step in quality control for whatever it is that you're building. Be aware that this part is still circulating on various companies' parts shelves. I don't know or remember who makes or sells it, and I'm not here to call anyone out. I'm just warning you never to buy the stub shaft without the oil groove in it. This is what a Mitsubishi stub shaft looks like. Note the differences. Aside from the spool lumped on the backside, there's an oil groove because the 1.6 liter Mirage pump works exactly the same way as a 2G turbo. The shaft diameter of both are the same. The oil grooves line up in the 7-bolt front case. It fits the gear. The length is correct. If anyone can tell me why this part doesn't work in a 7-bolt, I'm all ears. It looks to me like it would work just fine. I don't know why I didn't use this Mitsubishi part here like I do religiously for everything else that matters. My pump housing is visibly scored and worn out beyond spec, mostly because the whole pump ate metal shavings. The outer faces of the gears are deeply grooved from abrasion, and both of the gears measure beyond the wide spec. Loose gears on an oil pump is a big problem because pressurized fluids are picky about where they want to flow. Fluids don't like to compress, and like all things, they flow from a higher concentration to a lower concentration. Because oil flow is the whole point of an oil pump, then loose out-of-spec gears in the pump housing causes oil to backwash to the low-pressure side and reduce oil volume being delivered to the regulator. There we go with oil volume again. The pump's job isn't to supply pressure. That's the regulator's job. The pump's job is to satisfy the regulator to keep up with the supply of oil needed by all of the parts downstream from it. It's an end-of-life spec. Being within the tight side of spec is ideal because the pump will work most efficiently without friction from drag. The wide spec for the oil pump gears is the point at which your oil pump loses efficiency to do its job. Attempting to repair it is a bad idea, and for a number of reasons. You have to think about how it affects the oil supply to the parts, the oil galleries cast into its case, where it moves the oil supply holes and grooves, and how it can offset your actual timing belt's operating position. It would be much easier to just replace the whole thing with new parts and a new housing. It's not cheap, but this is your oil pump we're talking about here. It's the heart of your engine. How much is your rotating assembly worth to you? Give your engine a fighting chance and do this right the first time. A good machinist might be able to refurb this part, but you won't be on his Christmas card list and your bill will reflect his displeasure with you. So whether you're rebuilding or replacing your oil pump, you just want to make sure you start off with a good one. This one's well used, 150,000 miles old, and we're going to see what it's made of now that it's been bead blasted. There's no ridge wear in either of these casings, and everything here appears to be in really good shape. I don't have a clean room available to me yet. I don't have the space necessary to build one, so I'm taking every effort to be as neat as I can about this. This is something I can do over a workbench, and I'll be assembling it immediately if everything checks out okay. Prep your workbench with all the stuff you'll need so you don't have to walk all over the place and stir up a bunch of dust. I do my dirty cleaning stuff on one side of the bench and my clean stuff on the other. The only tool I haven't talked about yet are the Dremel and the pick. And don't forget your gloves. There are a couple of rough spots in the transition from the oil pump's primary gallery. This isn't a real big problem to have with a good pump, but turbulence slows down oil flow, and it's not much work to take the burrs off of this casing to help that transition out a bit. It's really hard to light this for the camera, but I hope you can see down in there. No? Okay. There's just some flash down in there, and a ridge where the drilled hole meets the casting. The outlet of this gallery just has some sharp edges on it that I want to smooth out. If you feel the need to correct this, here's one way you could do it. I'm using a fine grit stone that's a little bit softer than the aluminum because my intention is to round the edges and polish the surface rather than remove a whole lot of material. There's no benefit in enlarging this. The flex shaft makes this so much easier because it's balanced really well enough that you can avoid grinding into the case with a collet that holds onto the bit. You can do this without it if you're very careful, but if you have it, use it. This job is a 2-can of carb cleaner job with or without the grinding. Since this front case was bead blasted, I scrubbed every square inch of this thing, including the bolt holes, because I don't want a single glass bead left in this part when I'm done. I blast the carb cleaner off while it's still wet so that it takes some of the funk with it. Then once I'm happy with it, I clean out the oil pump housing one last time. You can see the transition after the light grinding. All the surfaces are now blended. Now let me introduce you to the straight cut 6-bolt oil pump gears. These are the original gears that came out of this case. I'm just using carb cleaner and a nylon brush to prevent scratching them. Inspect the teeth for cracks or wear and give the driven gear the same treatment. Be sure to wash out the oil gallery in the drive gear, scrub between the gear teeth of both gears, and down in the cavity where the bolt goes onto the driven gear. There's one thing I like about straight cut gears. The teeth aren't at an angle, so the drive gear can't push or pull on the driven gear, creating lateral thrust loads. Now that the pump housing parts are clean, let's get their specs. Starting with the 5,000th feeler gauge. Nothing on the driven gear. Let's try the 4,000th. It's tight. Bounces and wiggles a straight edge, but it fits. 3,000ths? Sausage. It looks like we've got a tight 4,000ths on the driven gear. The drive gear feels pretty good with the 4,000ths. Just the perfect amount of drag. Let's try the 5 again to be sure. Not in my house you don't, so the gears are good. We've got some more cleaning to do though. This is the one problem area you'll encounter. The plug where the oil gallery is drilled through the rear housing. Junk gets trapped in that hole where you can't see it. Get something that can reach down inside of there and dig it out, then wash it out, then blow it out. The last thing you need is to hide a little surprise present for your oil pump shafts to open up later. Glass beads aren't the best media to use to clean up a front case. If you use glass beads, you have to take special care to get all of them out. Think about how many it takes to wipe a groove in a bearing surface. 1. And it doesn't stop causing damage unless it makes it back to the filter. Walnut shells or charcoal work much better as a media because they're oil soluble and softer than the bearings. Since we measured the shaft diameter of the trash pump, let's check this one out and see how it compares. We had a touch over 1/1000th of an inch on the last one. Also remember that this is not covered as a necessary inspection in the service manual for either a 6 or a 7-bolt. This is extra credit. The housing shaft journal measures nearly 788 thousandths. Once again we subtract the shaft diameter, which is nearly 786 thousandths of an inch. Off by the same size gap on both measurements, so we're right at 2 thousandths for the shaft's oil clearance. That's right about where I'd like to see that. One measurement listed in the 1G service manual is inspecting the gap between this tight ridge in the case and the drive gear. Those specs are roughly 7 thousandths on the driven gear and 8 thousandths on the drive gear. I'm at 6, so I'm well within spec. Don't waste your time measuring the driven gear. It's centered by the rear housing and you'll never get the tool in there with it assembled. That's probably why it's not in the 2G service manual, but based on what I've seen here, I'm sure it's fine. Put a rag in your vise to avoid scratching your parts. If you're deleting the balance shaft, you have a brand new clean stub shaft already. Just make sure to use a clean bolt. But if you're reusing either the balance shaft or a stub shaft, you should run an M8x125 threaded tap through the bolt hole first to clean out all the thread locker that you should have had in there before. Prior to assembly, you should apply red thread locker, especially if you install a stub shaft. You don't want this part backing out and dropping in the pan. The party ends real quick if it does. Turn the bolt down all the way by hand until it bottoms out. Then clean the excess thread locker off the tube before you put the cap back on if you ever want to use it again. Set your torque wrench for 29 foot-pounds and torque the bolt before the thread locker sets up. The next thing you'll want to do is apply plenty of grease around the pump housing before you insert the gears. The grease seals up all the gaps to prime the pump so that it instantly slurps the oil out of the pan on first startup. Just don't use enough to clog up your oil filter. Once your oil is hot, it becomes part of the stew. After you press the gears into the housing, you want to see it ooze out through the gear teeth. It's like packing a bearing. See the dimples? I lined up my dimples again. Don't give me grief, you know you did this too. Wipe off the excess grease and spread it into any remaining gaps. Take care to wipe the oil pump sealing surfaces clean of any grease and that's free of dirt, fuzz, or anything else. There's no gasket for the oil pump. This is because a gasket or sealant on this surface would add thickness to the housing and widen the gap for the sides of the gears. This is why it's important not to scratch the gasket surfaces and to keep them spotlessly clean. Speaking of clean up your bolts for the rear housing. It's probably better to do this when you take it apart, but just make sure you're using clean bolts during assembly. Set your torque wrench to 13 foot-pounds. You want to be able to turn them all the way down by hand. If one of them fights you, it will affect that bolt's torque load. If they hang up and don't want to thread, try a different bolt first. If that one does the same thing, run the M8x125 tap through the hole and try again. Okay, I lied. I have 2 snap-on tools. Totally busted. That's better. I start on the 2 bolts opposite of the dowel pins and tighten in a star pattern. Then I go over them a second time. Spit on the seal and press them into the seal boss until they bottom out. I'm using a 38mm socket. It would be better to use a 42mm, but this is what I have. I use a 19mm socket to press in the oil pump seal. The service manual said to oil this, and I don't know why I did it. Grease works fine here. I never needed the oil. I'm just tired. You should be too. This was a long video. Wipe out the oil pump sprocket with carb cleaner and a rag until it comes out clean. Use a brass bristled brush to clean the gear's teeth. Wash it out and install it with a nut. If you did a balance shaft delete, press in your front case plug and you're done. Wrap up the front case in stretch wrap or saran wrap. Do whatever's necessary to keep it clean prior to assembly. Write yourself a reminder to torque the oil pump sprocket once the belt's on it. It's the same torque as the balance shafts, 29 foot-pounds.
Now you know why I couldn't break this up into more than one video. But this wasn't even the whole oil system. Rest assured I've got plenty more coming on this topic. This illustrates only one of the contributing factors of my short block failure. I was happy to provide a failed oil pump for illustration, but this covered a complete teardown, inspection, and rebuild of a DSM oil pump. We still have a regulator and an oil cooler to work out, several modifications to cover, and I still haven't talked about where the oil flows yet. But I'm grateful for your time spent watching my videos and a chance to perhaps save one of you a whole lot of headaches who's just trying to save a few bucks on a balance shaft removal. Use Mitsubishi parts for your oil pump and do it right.